Here are the notes for 2.7. It's just applying the fundamental theorem of algebra, which says if f of x is a polynomial of degree n where n is greater than 0, the equation has at least one solution in the set of complex numbers. And the corollary, which says if the polynomial is of degree n and n is greater than 0, the equation has exactly n solutions, provided if it hits the x-axis and bounces off, it's counted as twice. Or if that x value shows up 3 times, it's counted 3 times. So, and so on and so on. So even if it's the same exact number, you have to say it multiple times. Okay? So if we look at this one, how many solutions does the equation x to the third plus 5x squared plus 4x plus 20 have? It has 3. Because the degree n is 3. When in doubt, you could graph it out, put this into your y equals, and see where it crosses. However, it might have an imaginary solution that you can't see, so you have to be careful. How many zeros? So zeros, solutions, roots, x values, they're all the same. So if this has a degree 4, how many solutions, how many zeros does this one have? 4. Okay? All right, so this one actually has you find... Sorry, before I move on to the next problem, I should have had you do your turn. So go ahead and pause it and make sure you got it, and then check back for the answer. But if you look here, this is x to the 4th, so that means it has 4. X to the 3rd, that means it has 3, right? All right, now to move on to this next one, finding the zeros using a graphing calculator. This you're going to put into your y1. Once you do that, you're going to hit graph. Then you're going to see a graph that looks something like this. I think it crosses at like here. Oops, I guess that doesn't really help to do it that way. Okay, something like this. So what I'm asking for are these 3 values right here. I will make another video using the calculator just so you can see it better, or I'll post that video. But these are just the steps. So once you put this into y1, hit graph, it shows you this graph here. Because we're looking for the zeros, you're going to then hit second, trace, and then the one that says zeros, I think it's number 1. Then it's going to ask you to go to the left of your zero. So you start by, this is your starting point, right on it. Go to the left, hit enter, go to the right, hit enter, and then it'll give you, or then it'll ask you guess, and then it'll give you that point, which I got on mine, -0.532, which you can't see because I don't have my calculator on here right now. All right, then you go to this one. This one, you do the same thing. Second, trace 0. When you hit the left arrow, it puts you below. Right arrow puts you above. And then enter, and I got 0.653. And then we have to do this one last time. When you hit the left arrow button, it puts you above. The right arrow button puts you below. Hit enter for guess, and this one was like 2.879. Okay, those steps, especially if you are on retreat and are not in class to learn this on the calculator, you can also just use your arrows straight from the graph and just arrow left and right and estimate the points that way. Okay. Okay. So your turn. What you need to be able to do is put this into your y1, right? Then hit graph. And then trace the x-intercepts. So pause the video, try it, and then look back for the answer. So when you graph it, it looks something like this. This one's a little bit different. It crosses right here at x equals -1, and it crosses right here at x equals -3. But the weird thing is that it doesn't actually cross there it bounces at -3 and then bounces off again. So that's what the fundamental theorem of algebra was talking about. You have to say that point twice, right? Because remember, it has an exponent of 3. So if I just say -3 and -1, you did not give me all three numbers, right? You have to say even the -3 twice. All right, and the reason we do that is because from the left it's reaching -3 and from the right it's reaching -3. So if it goes straight through, like at -1, you just say it once. If it bounces, you say -3 twice. Okay? All right, so moving on with these then. Example 4, use the zeros to write a polynomial function. So it has these zeros. X equals 3, x equals -2, x equals 4, which means the step before it was x minus 3, x plus 2, x minus 4, right? Because in order for x to equal 4, the factor must have been x minus 4, because then to solve for x, you're adding 4. So once you figure out, like once you know how to go backwards from the zeros to the factor, now it's just order of operations. So x times x is x squared, x times 2 is 2x, minus 3x, minus 6. You can distribute to the negative, or the x minus 4 now if you want, but I'm just going to combine this to make it a little bit easier. And now you have x cubed minus 4x squared minus x squared plus 4x minus 6x plus 24. Last step would be to finally combine your like terms. So I have an x cubed, which doesn't combine with anything. And then I have these two guys, which becomes minus 5x squared minus 2x plus 24. Okay, you could then put this into your y equals and graph and check. It should cross at 3, -2, and 4. Okay, so this is a way to check. All right, let's look at the next one. Oh, this one is a typo. This is an extra 2. It was just supposed to be, that was the number 2. So it still has 3 things. These are my x values. X equals -1, x equals 2, x equals 4. So when I write the factors, it's x plus 1, x minus 2, x minus 4. Pause it, try multiplying this one out on your own, and then check back to see if you get the answer. So here's the answer I got after multiplying it out. If you want to take a second to pause the video again and check your answer, please do so. Otherwise, you can move on to the next problem with us. These are your zeros. So x equals 0 is one of them. X equals -3 is one of them. This right here, multiplicity of 2, means you write that answer twice. So when I do my factors, I have x plus 0, x plus 3, x plus 3. X plus 0 is just x, right? So I'm going to leave that one. I'm going to FOIL these out. X times x is x squared. X times 3 is 3x. X times 3 again is 3x. 3 times 3 is 9. Combine my 3 x's so I don't have as much work to do. And then distribute the x in. X cubed plus 6x squared plus 9. Okay? There's that. So, check, video, use, calculator. I'm going to post a video with the calculator as well, so you have that. All right, see me with questions.